auto post vector density forms a Fourier transform pair. This is the first property, and this is also called as Wiener-Khinchin relationship. Already we have proved this yesterday. So what is the relationship? Autocorrelation function and auto post vector density form a Fourier transform pair. Okay. Second one, auto post vector density at omega equal to 0 is area under autocorrelation function. You have learned applications of integration in intermediate. The first and foremost application of integration is to find out area. Integration of something gives area under that. So here we have integrated autocorrelation function. So this gives us area under autocorrelation function. So simply how do you write it? Auto post vector density at omega equal to 0, angular frequency 0 is equals to area under autocorrelation function. Let us prove this. Just let us write the formula of autocorrelation function using a Fourier transform. It is integration from minus infinity to plus infinity r double x tau e power minus j omega tau d tau. Just we have to substitute omega equal to 0. Substitute omega equal to 0. So it gives us s double x 0 is equals to integration from minus infinity to plus infinity r double x tau e power 0 is 1 d tau. This way you have to prove. The third one, mean square value of the random process. Mean square value of wide distance stationary random process. How it is? How we have to represent mean square values? Expectation of x square. It is a mean square value of the random variable x. If we include time, this is the mean square value of the random process. Okay. So the mean square value of the random process, expectation of xt into xt. Can someone tell me what is this? Is it not autocorrelation function where the delay is 0? R double x 0 is mean square value. So that's equals to 1 by 2 pi integration from minus infinity to plus infinity s double x omega d omega. This right side, can someone tell me what is this? Here we are integrating, right? Integration of power spectral density. Integration of something is area under that. Here we are integrating power spectral density. So this integration gives area under auto power spectral density. Okay, so Autocorrelation function at tau equal to 0 gives the area under autopospectral density. Second and third looks same. Okay, so autocorrelation function at the delay 0 or mean square value of wide chain stationary random process is equals to area under autopospectral density. Okay, autopospectral density. Let us prove this. So let us write R double X tau formula. What it is? Expectation of xt x t plus tau. Let's substitute tau equal to 0. It gives us R double X 0 is equal to expectation of x square, which is nothing but mean square value. Okay. Let us also write the R double X of tau using inverse Fourier transform. We have to apply inverse Fourier transform on S double X omega. So R double X tau is equals to inverse Fourier transform is 1 over 2 pi integration from minus infinity to plus infinity S double X omega e power j omega tau d omega. Now let's substitute tau equal to 0. So R double X 0 is equals to 1 by 2 pi integration from minus infinity to plus infinity S double X omega d omega e power 0 is 1. So this way you have to prove this autocorrelation at tau equal to 0 or mean square value of the random process is equals to area under autopospectral density. And another one, this autopospectral density is always greater than equal to 0, means non-negative. So a wide sense stationary random process has a non-negative perspective density. Non-negative perspective density. And the fifth one, S double X minus omega is equals to S double X omega. Can someone tell me this in mathematics in words? It is even function. Yes, even function of omega. So the perspective density of real values, real random process is an even function of omega. Even function of angular frequency omega. So let us prove this. Just wait for a minute. Power వచ్చిందమ్మా. I will connect to Wi-Fi. Thanks for waiting. First, let us write the formula for S double x omega using the Fourier transform. Integration from minus infinity to plus infinity r double x tau e power minus j omega tau d tau. So we need the relationship between S double x omega and S double x minus omega. So let us replace omega with minus omega. Then it gives us S double x minus omega is equals to integral from minus infinity to plus infinity r double x tau e power minus j and minus j minus omega tau d tau. Right. Now let us take tau equals to minus u, then d tau equals to minus du. And not only that, lower limit becomes infinity, upper limit becomes minus infinity. So S double x minus omega is equals to integration from infinity to minus infinity r double x tau e power minus j minus omega minus u du. Right. So we can write it as integration from infinity to minus infinity r double x tau and anything mistake in the
R
this?
double X of U.
Yeah, we have tried minus u. E power minus j omega u d minus u. I think let me put minus here itself. Minus du minus. If we swap the integration limits, what we get? I'm going to swap the integration limits. Are both are equal or something is there?
Negative.
Negative. Very good. So S double x minus omega. So on swapping the limits, negative will come, and already one negative is there, so that becomes positive. R double x minus u e power minus j omega u du. I'm going to write a formula. You tell me this one. Is it correct or not? Is it correct? Autocorrelation function is even function of delay. What is the go to the properties of autocorrelation function and check autocorrelation function of minus tau is equals to autocorrelation function of tau. So let us substitute that S double x minus omega is equals to integral from minus infinity to plus infinity r double x u e power minus j omega u and d. So what is this formula? It's a Fourier transform formula, right? It's a Fourier transform formula. S double x omega. Tau place లో ఏముంది? Just u ఉంది. This way you have to put. So auto force filter density is even function of omega. And one more. S double x star omega is equals to S double x omega. On what two numbers we apply conjugate? Can you hear me? On what numbers we apply conjugation? Complex, right? So we are going to apply conjugation on a real random process, or it may be a complex real random process. Okay, xt is a real function. After applying conjugation, you are getting SWX omega. SWX omega is a real function. So let us go this. First, let us write the formula of SWX omega. Integral from minus infinity to plus infinity. R double x tau e power minus j omega tau d tau. So we want the relationship between SWX omega and SWX star. Means we have to apply conjugation. So in the above formula, we apply conjugation. Just I am applying conjugation. So this conjugation is applied on. It is always applied on real. It is always applied on complex numbers. But we are taking xt. Xt may be a real random process or a complex random process. So we have to apply this conjugation on both autocorrelation function and this e power minus j omega. Can someone tell me what is the conjugation of e power j theta? And what is the conjugation of e power minus j theta? E power j theta is cos theta plus j sin theta. What is the conjugation of cos theta plus j sin theta? Conjugation means x plus jy. Conjugation is x minus jy plus j into minus j అవుతుంది minus j into plus j అవుతుంది. That is conjugation. So it becomes e power minus j theta. If e power minus j theta is there, it becomes e power plus j theta. So e power minus j omega t becomes plus j omega tau d tau. Okay, but from the properties, this one we have not seen. The conjugation of autocorrelation function is r double x of minus tau. So s star double x omega is equals to integral from minus infinity to plus infinity r double x minus tau e power. I am writing this one as e power j omega t as j minus j omega minus tau. Negative into negative or positive. Minus j and minus tau, it is j omega tau only. So in place of if you see this clearly, you get the formula of Fourier transform on autocorrelation function. Otherwise, you take minus tau as a u and solve it. So any doubts in the power spectral densities? Let's go one by one. The first property is a Wiener-Keynesian relationship. It tells that autocorrelation function and power spectral density means auto power spectral density. These two form a Fourier transform pair. Second one is area under autocorrelation function is equals to power spectral density at omega equal to 0. And third one says that the mean square value or autocorrelation function at tau equal to 0 gives area under power spectral density. And the fourth one says that the power spectral density is always non-negative. It is by observation. The power is always positive. Power is always positive. Okay. మీరు నెట్వర్క్ కీలో చూసుకుని ఉంటారు. Delivering the power delivery is always positive. Okay. and observation is negative. Power observed is negative. This perspective density is always delivered one, so it is always non-negative. And fifth one is says that the perspective density is even function of omega. And if you apply the conjugation on the real or complex random process, then it says that S star double x omega is equals to S double x omega. It is always real function. So these are the properties of autocorrelation, autocorrelation and auto-perspective density relations and auto-perspective density properties. Now, let us move on to cross-perspective density. Cross power spectral density. It is represented with capital S means perspective density. Cross means xy, survey xy of omega. Okay. Syx also cross perspective density. You can apply the perspective density on xy or yx combination. Anyway, sxy or syx both are cross perspective densities. Okay. Now, so we apply Fourier transform on xt that gives us x omega. Similarly, we apply Fourier transform on yt that gives us y omega. Y omega is the y in frequency domain. Okay, x omega is x in frequency domain. Now, the cross perspective density Sxy of omega limit t tends to infinity. It's an expectation of x star omega y omega by 2t. This is the formula for auto. No, it's a cross perspective density. Okay, and average power Pxy is average power. So how do you get average power? Power is the area under perspective density. What perspective density here? Cross perspective density. Sxy omega d omega. This is for xy combination. And if you apply for yx combination, the cross perspective density for yx combination is limit t tends to infinity, expectation of y star omega x omega by 2t. And average power in yx combination is area under cross perspective density. S yx omega d omega. Okay. Now let us see the properties. Properties of cross perspective density. You can guess what is the first property. It's a Wiener-Khinchin relationship. What is a Wiener-Khinchin relationship? Can someone tell me? It's a relationship between correlation function and the perspective density. Here we are using cross one. So cross correlation function and cross perspective density form a Fourier transform pair. This is the relationship. So R xy tau apply Fourier transform on this, it gives us Sxy omega. So can someone tell me what is the formula for Sxy? Sxy omega is a Fourier transform. What is the Fourier transform formula? Integral from minus infinity to plus infinity. We are applying Fourier transform on cross correlation function. Rxy tau e power minus j omega tau d tau. Okay. Now we have to prove this. So the first property is relationship between. Let me write here itself. This is also called as relationship between cross correlation function and cross prospector density. Okay, itself is a property, itself is a relationship, itself is a Wiener-Keynesian relationship. Now to prove this, I am going to use this formula Sxy omega equals to limit t tends to infinity expectation of x star omega y omega by 2t. Right. So already we have seen what is x star omega. Directly I am writing x star omega is integration from minus infinity to plus infinity. So let me write this as xt1 e power j omega t1 dt1 and y omega. It is integration from minus infinity to plus infinity. Y, let me take t2 e power minus j omega t2 d t2. So we should find out expectation of x star omega y omega. So it is the expectation of integral from minus infinity to plus infinity xt1 e power j omega t1 dt1. This is x star omega, and y omega is integral from minus infinity to plus infinity yt2 e power minus j omega t2 d t2. So expectation is always applied in the random process. So let us apply that. Integration from minus infinity to plus infinity. Okay. Expectation of xt1 xt2 e power. So let us take minus j omega common, then it leaves us t2 minus t1 the exponent and dt1
YT2.
dt2. Yeah, it's a cross correlation, cross prospector density yt2. Right. Now let's take t1 equals to t and t2 equals to t1 plus tau or t plus tau. So dt1 equals to dt, and I'm going to differentiate t2 with respect to only t, not with t1. Okay. So anyway, lower limits and upper limits are minus infinity plus infinity. So integral from minus infinity plus infinity, integral from minus infinity plus infinity. This is the expectation of xt y t plus tau e power minus j omega tau dt and d tau. So this is the expectation of x star omega, y omega. So we have to substitute this in s double sxy omega. So according to this, it is limit t tends to infinity 1 by 2t, and this one integral from minus infinity plus infinity, integral from minus infinity plus infinity, expectation of xt y t plus tau e power minus j omega tau dt d tau. If you clearly observe this, can someone tell me what is this? What is
Rx.
this? Rx by tau. Now sxy omega is equals to, so I am going to arrange this like integration from minus infinity plus infinity, limit t tends to infinity 1 by 2t, integral from minus infinity plus infinity, r xy tau e power minus j omega tau dt. This is the inner integral d tau. Yeah, what is this integration? Is it not time average? It's a time average, right? It's a time average of cross correlation function rxy tt plus tau. 1 minute. Let's don't write here. This is t comma t plus tau. Now if xt and yt are jointly wide cell stationary and ergodic, then this time average means capital A of r double not double s rxy of t comma t plus tau is equals to rxy tau. Okay, so time average is equals to ensemble average. Time average equals to ensemble average. Then sxy of omega is equals to integration from minus infinity plus infinity is a of r xy of t comma t plus tau e power minus j omega tau d tau. Let us substitute in place of the time average, we can substitute rxy tau e power minus j omega tau d tau. So this is the relationship between cross power spectral density and cross correlation function. So Fourier transform formula, right? So sxy omega is equals to, it's a Fourier transform of rxy tau. Yeah. Second property.
సార్ అక్కడ టైం యావరేజ్
చెప్పమ్మా. టైమ్ యావరేజ్
క్రాస్ కోరిలేషన్ ఈక్వల్ ఎట్లా అయింది సార్?
ఇక్కడ ఎర్గోడిక్ అని రాశాను కదా.
ఎన్సెంబుల్ యావరేజ్ కి ఈక్వల్ కదా సార్?
అవును, ఎన్సెంబుల్ యావరేజ్ లో ఫార్ములా ఏంటి? ఎక్స్పెక్టేషన్ ఉంటుంది కదా. ఈ క్రాస్ కోరిలేషన్ ఫంక్షన్ లో ఈ ఉందా లేదా, ఎక్స్పెక్టేషన్ ఉందా లేదా?
ఎస్ సార్.
కోరిలేషన్ ఫంక్షన్ లో ఎక్స్పెక్టేషన్ ఆపరేటర్ ఉంటుంది. ఓకేనా?
ఓకే సార్.
సో సెకండ్ ప్రాపర్టీ is cross correlation function is even function of omega. So this proof I am leaving because already I have proved. Yeah. The same proof you can use. You just write sx y omega equal to rxy tau e power minus j omega tau. Replace omega with minus omega. Sxy minus omega equals to r integral rxy tau e power minus j minus omega tau. You just change the second subscript. Second here, second subscript is x. Just replace that second subscript x with y. Then you'll get the proof of this cross prospective density is even function of omega. Okay, this proof is homework to you. Third one, yeah, I don't know whether you know it or not. X plus jy, z equal to x plus jy. Can we write x as a real part of x, real part of z? Can we write? And y is imaginary part of z. Can we write? This is the representation of x and y of complex number z. X is a real part of z and y is a imaginary part of z. So this cross correlation function or the prospector density. Okay, we know that these two form a Fourier transform pair. So in the frequency domain, always you have complex numbers. Frequency domain consists of complex numbers. So whenever there is a complex number, there is imaginary part and real part. So real part of prospector density and imaginary part of prospector density. This is even function of omega. Real part is always even function of omega and imaginary part is odd function of omega. So odd function of omega. And s xy omega is equals to 0. Can someone tell me what it represents? If correlation is 0, what it represents? The correlation of a random process of the two random processes xt and yt is 0. What it represents?
Uncorrelated.
Oh, okay. Uncorrelated means it is a expectation of x in okay. Not only that, it also represents orthogonality. So for orthogonal xt and yt, rxy tau equal to 0. When autocorrelation is 0, what is the power factor density? When this cross correlation is 0, what is the cross power factor density? It is a Fourier transform of cross correlation function. Already cross correlation function is 0, so Fourier transform of 0 is 0. Okay. The last one, if xt and yt are uncorrelated, if these two are uncorrelated and have constant mean x bar and y bar. X bar is the mean of xt, y bar is the mean of yt. Then the cross prospector density and the cross prospector density can be represented in two ways, xy way or yx way. So both are equals to 2 pi times x bar y bar del of omega, where del of omega is equals to 1 when omega equal to 0 and 0 elsewhere. So these are the properties of cross prospector density. So any doubts in this?
What is the del of omega, sir?
Impulse. Del is the impulse signal. Already we have seen del x is equals to 1 at x equal to 0 and 0 otherwise. Already we have seen unit step function and impulse functions. This is impulse function. Impulse function is always 1 at omega equal to 0 and 0 elsewhere. Here, are you there?
Yes, sir.
Okay. Tell me the absentees numbers.
62,
Okay.
77, sir.